Today we will cover chapter 11, and usually what we did in the past was to make inferences about population parameters, the mean and the proportion. In this chapter we are going to do exactly the same, but we are going to look for the population variances. So this is the population, okay? And we are going to get a sample from the population, and from the sample we are going to get the sample variance S squared, and we are going to make inferences about the population parameter sigma squared or the population variance. What inferences are we going to make in this first part is about the confidence intervals and the hypothesis testing. And the confidence interval, remember, is to find out with certain degree of certainty where the exact population parameter is based on my sample statistics. Okay, so I'm going to say that I am a certainty or certain level of certainty that the real population variance is between these two values. And of course, in the hypothesis testing, we are going to do exactly the same. We are going to test the hypothesis about the population variance based on the sample variance. Okay. Now, we are going to learn two new probability density functions in this chapter. We're going to learn about the chi-square distribution. That is a distribution more or less this shape, okay? Starts in 0. There is no this symmetrical distribution anymore, like the normal distribution and the t-distribution. This is not a symmetrical distribution, and it starts in 0, and it's more or less like this. This chi-square distribution has one parameter, that is the degrees of freedom, and in this case we are going to have n minus 1 degrees of freedom, where n is what? The sample size. That easy. Okay, we have a table in your book, is on chapter, it's appendix B on page 983, and it's going to tell you what is the area over here, okay? And it's going to give you the exact number over here. And we have what? 0.995, that means what? The right tail over here. This is the 995 number. We have the 0.99, we have the 0.975, and so on until the 0.005. Okay? It's very easy to read this table, and we're going to do it in just a moment. Okay, this is the distribution that we are going to use when we use one population variance. Okay. We know, and don't ask me why we know, but we know that n minus 1 s squared divided by sigma squared follows a chi-square distribution. Okay, so if we know that this is a function that follows this distribution, then we are going to make inferences based on this probability distribution and based on this formula. That's it. It's pretty easy, it's pretty simple. Now, let's do confidence interval. And we know about this. So we know that n minus 1 s squared divided by sigma squared is a high square distribution or follows a high square distribution. Now, confidence interval. We want to know where is the interval where the real population the variance is located. Okay, so we know from the high distribution that, again, if we follow this is the confidence level, this is the confidence interval for what? For high square. So my confidence level, whatever it is, high square of alpha divided by 2 is less or equal than a high square, less or equal than high square of 1 minus alpha divided by 2. Okay? But this high square is this function over here. So, let's this. High square of alpha divided by 2 is this is not an alpha divided by 2. This is 1 minus alpha divided by 2. So this is 1 minus alpha divided by 2 and alpha divided by 2. 1 minus alpha divided by 2 is less or equal than my high square n minus 1 s squared divided by sigma squared is less or equal than my high square of alpha divided by 2. And after a few mathematical interpretation or movement, we are going to get, if we follow this part only, my sigma squared is going to be less or equal than n minus 1 s squared divided by high square of 1 minus alpha divided by 2. Okay? This is the first part. So we know that sigma squared is less or equal than 1 minus alpha divided by 2. Okay? Yes. And the right part over here, we're going to have what? N minus 1 s squared of high square of alpha divided by 2 is going to be less or equal than sigma squared. Just doing some mathematical movements over here. So my confidence interval then, because of that, is that n minus 1 s squared divided by high square of alpha divided by 2 is less or equal than sigma squared and less or equal than n minus 1 s squared divided by high square of 1 minus alpha divided by 2. This is my confidence interval, and it's exactly the same formula that you're going to find your book on page 454, and it's the formula 11.7. That's it about the confidence interval. So we need to know what is my alpha, and remember, if my confidence level is 95, my alpha is 0.05. If my confidence level is 90 or 0.9, my alpha is 0.1, and so on. So that's pretty easy. Let's do one problem. Problem number 2. And I'm going to do just one part of problem number 2. Okay, problem number 2 said a sample of 20 items, so n is equal to 20, provides a sample standard deviation Guys, be very careful because this is the standard deviation. S is equal to 5. Okay? If they tell you the sample variance is equal to 5, it means S squared is equal to 5. But in this case, they tell you the sample standard deviation, S, is equal to 5. And let's do a 90% confidence interval. Okay, what is the formula? The formula says n minus 1 s squared divided by I squared of what? Of alpha divided by 2. What is alpha? Alpha is equal to 0.1. So alpha divided by 2 is equal to 0.05. Okay? Of 0.05 with how many degrees of freedom? N minus 1 with 19 degrees of freedom is less or equal than sigma squared and less or equal than n minus 1 s squared divided by I squared of how much? 1 minus alpha divided by 2 and again 19 degrees of freedom. What is 1 minus alpha divided by 2? Alpha divided by 2 is 0.05. 1 minus 0.05 is 0.95. 19. Okay? Now, and this is just math. So n minus 1 is 19 times s squared is 5 to the power of 2 divided by I squared. Let's go to the table. And I need I squared of 0.05. How many degrees of freedom? 19. So go to the degrees of freedom 19 and then go to the column that it says 0.05. And that is 30.144 divided by 30.144 is less or equal than sigma squared, less or equal than n minus 1, 19 times s squared, 5 squared, divided by I squared of what? 0.95, go to the I squared table, 19 and 0.95, and that value is equal to 10.117. Okay, and this is just math. This is 15.76 less or equal than sigma squared, less or equal than 19 times 5 squared divided by 10.117, 46.95, and I'll let you know this. Okay? So the confidence interval for the population variance is between 15.76 and 46.95. What I'm telling you is that the population variance is in this range, between 15.76 and 46.95, and I am 90% sure that this is the case. Now, and this is the confidence interval for the variance. What is the confidence interval for the standard deviation, for sigma? Okay, and you know that sigma is equal to the square root of sigma squared, and what we do is just take the square root of 15.76, and that is 3.97. It's less or equal than sigma, less or equal than 6.85, and I am 90% sure that the population standard deviation is between 3.97 and 6.85. And that's it about confidence interval.